Dear students, welcome to online classes. Today we are going to discuss about the chemical properties of metals and non-metals from the lesson Metals and Non-Metals from 8th class physics. Now note, this is a demonstration to be carried out by the teacher because sodium is extremely reactive and dangerous and students should see the demonstration from a distance. Take a 500 ml beaker or a big glass trough and fill half of it with water. Take the sodium which is stored under kerosene and keep it on a sheet of filter paper to blot the kerosene and cut a very small piece of sodium from it. Put the remaining sodium back again in the kerosene and standing away from the trough, put the sodium piece in water using forceps. Let you see this. So this is the sodium which is stored under kerosene, and along with the sodium we can use lithium and potassium because they are extremely reactive even with the water present in the air. So that's why we should always preserve them under kerosene.
We'll go down the column on the periodic table in group 1 and look at sodium. Like the lithium, the sodium is stored in a mineral oil to minimize reaction with the oxygen in the air. If we remove a piece of sodium metal, we notice that it's also coated over with an oxide coating. Group 1 metals become softer as you go down the column. The sodium is much easier to cut than the lithium. As we cut off the oxide layer, we can see the shiny metal underneath. It coats over very rapidly with a layer of oxide. The sodium is a metal and is an excellent conductor of electricity. If we take a piece of the sodium metal and add it to water, we notice a much more rapid reaction with the water. Like lithium, the sodium is less dense than water and floats. The metal moves across the surface, being pushed by the hydrogen gas that is produced. As you go down the column with group 1 metals, the melting point of the metal decreases. The reaction is very exothermic, which causes the sodium metal to melt. The metal contracts into a very compact spherical form. We can again test that hydrogen gas is being produced by this single displacement reaction by trapping the gas and testing its flammability. We can test for the fact that we produce sodium hydroxide by adding phenolphthalein. The phenolphthalein turns a purple-red color due to the presence of the hydroxide ions, indicating the formation of the sodium hydroxide.
Now the piece of sodium floats on the surface of water with a hissing sound. You can observe. This shows that sodium is reacting extremely fast with the water. After the reaction is complete, test the solution with litmus paper or phenolphthalein indicator and repeat the same experiment using aluminium and iron. You will not see any change even after 5 minutes. This is because these metals react extremely slowly with water. Does non-metals react with water? Generally they do not react with water. And now let us go with one more property, reaction with acids. So take the samples in separate test tubes, add 5 ml of dilute sulfuric acid to each of the test tube with the help of a dropper and observe the reaction. If you find no reaction, heat the test tube gently. If you still see no reaction, add 5 drops of concentrated hydrochloric acid. Now Bring a burning matchstick near the mouth of the test tube and observe that what happens. Now we have taken dilute hydrochloric acid in all the 6 test tubes, and we have taken the metal samples or non-metals: copper, zinc, magnesium, iron, aluminium, and last yellow color was the sulfur. And we added into the test tubes so that we can observe fumes are liberating from the first five test tubes, but there is no fumes, no bubbles will be released from the 6th test tube. And take one of the 5 test tubes because same gas is releasing in all that. So, and check these bubbles or gas with a burning matchstick. Just it booms out, means a pop-up sound is produced, so which is nothing but the hydrogen gas. So from this we can tell, do you find any difference in these reactions? Yes. When do you notice a pop-up sound with a burning matchsticks? With hydrogen. This sound indicates the presence of hydrogen, and you found that some metals react with dilute hydrochloric acid liberating hydrogen, but non-metals usually do not react with acids. And repeat the same experiment with sulfuric acid and record your observation in the table. Same you can find. And reactivity of metals. You have already seen that some metals react with air and others do not. The reaction is fast in some cases like magnesium and slow in case of silver and copper. Similarly, different metals react with water and acids under different conditions. Let us explore this reactivity further.
We can infer that Fe is able to displace Cu from its salt solution, Zn is able to displace Cu and Fe from their salt solutions, and Al is able to displace Zn from its salt solution. So Al is the most reactive metal and copper is the least reactive metal.
So we can understand with the above reactions that a more reactive metal can replace a less reactive metal, but a less reactive one cannot replace a more reactive metal. Hence, order of reactivity is aluminium is more reactive than zinc and than iron than copper. So copper sulfate plus zinc gives rise to zinc sulfate plus copper. Copper sulfate plus iron gives rise to iron sulfate plus copper. And zinc sulfate plus iron gives rise to zinc sulfate plus iron. Some uses of non-metals. Activated carbon is used as a decolorizing agent and also in water purification systems. This is the activated charcoal and this is the water purification system. And tincture iodine is used in medical purpose. So when you wound something, it will be used to clean the wound part. Sulfur is generally found in onions, garlic, eggs, and hairs, even nails. Sulfur is generally used in firecrackers, gunmetal, gunpowder, safety matchsticks, and even antiseptic creams. Uses of metals. So silver foil is used to cover the sweets, and aluminum foil is used for parcel making. And all these are made up of combination of metals. They are copper and aluminum mixtures. And these are all iron articles generally used for agriculture purpose. So these are all made up of iron. Electrical appliances, automobiles, satellites, aeroplanes, cooking utensils, machinery, decorating materials, all are made up of metals due to their malleability and ductility.